So this week we're gonna get into Unit 2, is auxiliary views. So we're gonna concentrate in this chapter the true lengths of line, and we will of course solve these problems. Then we will get into true sizes and shapes, your inclined and oblique planar surfaces, and then get into the principle of your true lengths of line. Then we will take a look at dihedral angles and the visualization issues, yeah. And then we will get into relationships, spatial relationships between points, lines, and points and planes, and skew lines, and etc. of course. Alright, so let's get into them. And these are your unit objectives. I'm not going to go ahead and read everything for you. And these are terms and definitions, alright? You have to take a look at that, of course. Alright, the very first thing that we gotta get in this chapter, auxiliary views, is normal views. So let's take a look at what are normal views. So we take normal views when your line of sight, okay, is perpendicular to the line or a surface. So it looks like this. Okay, if this was your line of sight and it is perpendicular to a surface or a line, right? So this perpendicularity is very important. So let me erase this. And all these lines, right, that's on that is normal to the line of sight, okay, meaning perpendicular to it, and we call them true length. So in order for us to get the true geometric characteristics of a surface, okay, we need multiple auxiliary projections. So they are primary, secondary, tertiary auxiliary views. All these views are necessary for us, okay, to be able to get these geometric characteristics of a surface. And the second one is your edge view. Just like the normal view is perpendicular, right, to your line of sight. So let's take a look at what this edge view does. So for edge view, we're looking at the points on lines, all right? They are aligned. So in which way they are aligned? Well, they are aligned parallel, right, to the observer line of sight. So if you take a look at it here, see, look at this. These lines are defining, the projection lines are defining the boundaries, all right, of this projection of that 3D. Anyway, so this is 2D on a single plane, but the edge view on this surface, all right, it exists because all these lines are parallel to this line of sight, all right? All these lines making this boundary of this projection, they're all parallel to this line of sight. Again, I'm gonna draw this so you can see it, okay? So when we talk about this is your line of sight, okay? Here are your lines, all right? See that line's a little, and these lines are actually defining this boundary, okay, of your front. Of course, in this case, I'm going to circle this your front view. So this is your front view projection, right? And it is made of all these lines, and these lines are parallel to this line of sight, okay? So that's what your edge view is made. Okay, I erase all the drawings. So edge view parallel to the line of sight of your normal view, perpendicular to it. Okay. So here you can see the edge views. Okay. Look at all the boundaries. And your normal view is just a regular view that is perpendicular, right, to your line of sight. Edge view parallel to the line of sight. So here again, normal views perpendicular to the surface. Okay, the line of sight is it's kind of like going straight in. Yeah. So if you take a look at from the right side, it's your line of sight because you're looking from that side, okay, towards. So it goes straight into it, and your line of sight is perpendicular to it. When you take a look at this edge, we're talking about this, okay, which is very different for you because you have to see, you're gonna have to see it how this boundary, even if we like show the line, it may look like it's perpendicular to your line of sight, but we're not talking about the entire plane. We're talking about just the edge. All right, the boundaries and the elements of that boundary are made because of the projection coming from your 3D. Okay, so behind of this view there is a 3D, this guy behind it, and your rays is going to come onto this all these surfaces and boundaries, and then reflect on that front plane, okay, surface we can call it, and make these edges. Yeah, so the line of sight that you're thinking about is not actually perpendicular. It is only perpendicular to the plane, but the boundaries, all right, made are actually parallel to the line of sight, and you're gonna have a little bit of trouble trying to see it in your mind, but you will get it if you try to be patient and looking at it in your mind. Okay, just try it again, because these things are, you can't just see it with your eyes, you have to see it with your intelligence. Okay. All right, now it's a little bit easier for you to say, here in this diagram, because we take it out. Oh, here is the edge view of right side, and here is the normal view of right side. See, like how we draw the entire plane for the normal view, and for the edge view we draw only a single edge. Yeah, this is an edge, looks like a line. So make sure you get that. All right, and that is definitely this normal view is perpendicular, and the edge view is parallel to your line of sight. Okay, try to differentiate the two views. So normal view, the right side, okay, and edge is, we concentrate only on the edge without the entire surface. Yeah, be very careful in that two view. You have a confusion. Yes, it will definitely flip your mind sometimes. Okay, well, that's about for normal view and edge view. The first, of course, section of this unit.